want to continue polynomial division, long division, I'm looking right here to see what I'm dividing by, x minus 1 into x to the 4, x to the 3, x to the 2. I'm missing that x to the 2, x to the 1, and that constant. So I'm going to have to compensate for that. So when I set it up in long division, I have x minus 1 divided into x to the 4 plus 2x to the 3 plus 0x squared, I don't have x squares, plus x to the 1 minus my constant. So I have to put that in there. So I'm going to kind of get this out of the way. So now I start that long division. The other thing that I did want to show you here was that whenever we're looking at a problem, in this case it has like a division symbol. So those are going to be noted a little differently throughout the problem. So here I'm going to move this out of the way and start my division. What times x is x to the 4th? And that would be x cubed. Now I'm going to multiply through. X cubed times x is x to the 4th. X cubed times negative 1 is negative x cubed. Draw the line, change the signs, and combine. So these are cancel, and 2x cubed plus 1x cubed is 3x cubed, plus bring down the next term, in this case it's 0x squared. So then I start over. What times x is 3x cubed? A positive 3x squared. So 3x squared times x is 3x cubed. 3x squared times negative 1 is negative 3x squared. Draw the line, change the signs, and combine. So these are going to cancel, and I'm going to have 3x squared. Bring down the next term. In this case, it's plus x. What times x gives me 3x squared? And that's going to be a positive 3x. X times 3x times x is 3x squared. 3x times negative 1 is negative 3x. Draw the line, change the signs, and combine. So these are going to cancel, and that's going to give me 4x, and I'm going to bring down that minus 3. What times x is 4x? And that's going to be a positive 4. 4 times x is 4x. 4 times negative 1 is negative 4. Draw the line, change the signs, and combine. And here when I combine, I'm going to have a remainder of 1. Because it's positive, I'm going to put plus 1 over x minus 1. Now this whole part up here, this whole polynomial, including that fraction, is the answer. And if you want to check it, you're going to say x minus 1 times x cubed plus 3x squared plus 3x plus 4. You're going to multiply that out, and then after you multiply, you'll add 1. And that will give you this polynomial up under here. Things will cancel, and you'll come out with that. All right, let's look at another. Notice that this is written a little differently. It has like a little division symbol right here. So I'm going to set it up, checking first to make sure I have everything. X to the 3rd, x to the 2nd, x to the 1st, and then my constant, so I do. So I'm going to set it up. 3x plus 4 divided into 6x cubed plus 2x squared minus 11x plus 12. Okay? I'm going to move the problem out of the way. And then we start. What times 3x is 6x cubed? Well, 3 times 2 is 6, and I need 2 more x's to make that cubed. So I'm going to multiply here. 2x squared times 3x is 6x cubed. 2x times 4 is a positive 8x squared. Draw the line, change the signs, and combine. So these are going to cancel, as they always will, and that's going to leave negative 6x squared minus 11x, bringing down that next term. What times 3x is negative 6x squared? That's going to be negative 2x. Negative 2x times 3x is negative 6x squared. Negative 2x times 4 is negative 8x. draw the line, change the signs, and combine. Now when I add them up, that's going to be negative 3x plus 12. What times 3x is negative 3x? It's just simply negative 1. Negative 1 times 3 is negative 3x. Negative 1 times 4 is negative 4. Draw the line, change the both signs, and combine. These are going to cancel, and that's going to leave 16. So I have a remainder that's positive. So I have a positive 16 over the binomial 3x plus 4. Number 4. When I set this up, I noticed right here that this has a negative 1. That just means that that's going to be the divisor. That would go to the bottom if it were written as a fraction. So don't let that throw you off. It just tells you what you're dividing by. I'm checking x to the 4, x to the 3, x to the 2, x to the 1, and my constant. So far I'm good. I'm going to set this up. So I have 2x minus 1 divided into 2x to the 4th plus 3x cubed minus 4x squared plus x plus 1. And once you rewrite it, you need to kind of, especially when they're longer, you need to go back and double check and make sure you have everything and you've copied correctly. So 2x will go into 2x to the 4th. 2 will go into 2, 1. I have 1x. I need 3 more to make that x to the 4th. So that's x cubed. X cubed times 2x is 2x to the 4th. X cubed times negative 1 is negative x cubed. Draw the line, change the signs, and combine. So these cancel. 3x plus 1, 3x, x cubed times 1. These have got to line up to be cubes. 3 plus 1 is 4x cubed. Bring down minus 4x squared. That's my next term. 2x times what gives me 4x cubed? A positive 2x squared. 2x squared times 2x is 4x cubed. 2x squared times negative 1 is negative 2x squared. Draw the line, change the signs, and combine. Cancel, cancel. Negative 2x squared plus x, bringing down this next term. 2x times what gives me negative 2x squared? It will be negative x. Negative x times 2x is negative 2x squared. Negative x times negative 1 is a positive x. Draw the line, change both signs, and combine. And what happens here is that they both cancel. However, I still bring down that next term, which is 1. And 1 turns out to be my remainder. So both of these cancel here. And so I've got a positive 1 over the divisor, 2x minus 1. And that would be my answer. In this last one, the only thing I want to do is set it up. What I want you to note is, again, it's written a little differently. So x plus 2 is what I'm dividing by. And I'm dividing into x to the 4th. I'm missing x to the 3rd, so I would add in plus 0x cubed. I have minus 0x, 6x squared. I'm missing that x value, so I have to add in 0x. And then my constant, negative 27. So this is just mainly to show you that you have to have all your exponents, 4, 3, 2, 1, and then your constant. So always look for that first. This is long division with polynomials.